This is Algebra Lesson 8-6, factoring trinomials of the form ax squared plus bx plus c. Now in Lesson 8-5, we learned how to factor a trinomial when the leading term or the leading coefficient was a 1. In other words, you didn't have a number in front of your x squared term or your p squared or your q squared or whatever term came first. Now, when the leading coefficient of a trinomial is not 1, factoring is a bit more difficult, but not impossible. We're going to use a special method where we must rewrite our original trinomial in such a way that factoring by grouping can be applied. So, if your trinomial is in the form of ax squared plus bx plus c, your first step is to form the product of a times c. When there wasn't a leading coefficient, you had the product of c. Now we have the product of a times c. We still want a sum of b, and then we're going to rewrite our polynomial to be factored again so that the middle term, b times x, is written as the sum of the two terms whose coefficients are found in step 2. And then you're going to factor by grouping. Now this may be really confusing until I go through a couple of examples, and then once I go through a couple of examples, it will make a lot of sense. So let's look at this first example. We're going to factor 3x squared minus 10x minus 8. Step 1 is to find the product of a times c. I always do this. So a times c is going to be 3 times negative 8, which is negative 24. And we need a sum of negative 10. So we're still going to think just like we did last time. We need to find two numbers whose product is negative 24 and whose sum is negative 10. So the larger factor has got to be the negative factor since both numbers are negative. So I might say, okay, how about 1 times negative 24? That's negative, that's 1 plus minus 24. 1 plus negative 24, that's negative 23. That won't work. How about 2 times negative 12? 2 plus negative 12 is equal to negative 10. That works. So I now know I need to use 2 and negative 12. Now here's where the difference comes. Before, we always just took our first term and we took care of the variable and split it in half and then just divided between the two parentheses. But now we have a leading coefficient of 3. So instead of doing that, we are going to rewrite negative 10x as a combination of 2 and negative 12. So we're going to keep our first term, 3x squared. We're going to rewrite negative 10x as positive 2x minus 12x because that equals negative 10x, and then we're going to keep our last term of negative 8. We now have a polynomial of 4 terms. When you have a polynomial of 4 terms, you're going to group it, and you always group it first 2, last 2. That's the easiest way to group. If it doesn't work that way, it's a rare occasion, and we won't get into any of those this year. So we group first 2, we group last 2. We look to find the greatest common factor of the first group of parentheses. What is the largest number and or variable I can take out of 3x squared plus 2x? I look at that and say, oh, I can factor out an x. So if I factor out an x out of 3x squared plus 2x, I'm left with 3x plus 2. Then I look and say, what's the greatest number and or variable I can take out of negative 12x minus 8. Since my first term is negative, I'm going to take out a negative number because we never want that first term to be negative. And I know that negative 4 will divide into 12 and 8, so I'm going to take out a negative 4. Negative 4 divides into negative 12, a positive 3x times, and negative 8 divided by negative 4 is a positive 2. And this is really important because we always want to get a common term. Okay, once we've factored by grouping, whatever is common, the 3x plus 2, whatever happens both times, we take that out once, 3x plus 2. Whatever is left over, the x and the negative 4, is the second part of that parenthesis, x minus 4. And that is the factorization of 3x squared minus 10x minus 8. And we could check this. In fact, let's check it. So if I took 3x and I multiplied it by x minus 4, and I took positive 2 and I multiplied it by x minus 4, I better come up with my original problem. 3x times x is 3x squared. 3x times negative 4 is negative 12x. 2 times x is 2x. 2 times negative 4 is negative 8. When I simplify this, I get 3x squared minus 10x minus 8, which was our original problem. So I must have done something right, and the factoring must be correct. This is a process. It takes a little time. Once you've memorized the process, it's not very hard to do. Okay? But it is a process, and you have to commit it to memory in order to do it. So let's take a look at a couple more examples. Let's take a look at 3x squared plus 5x plus 2. I need a product here of 3 times 2, which is a product of 6 and a sum of 5x, or just 5. All right, so I need two numbers that multiply together to get 6 and add together to get 5. Let's see, 1 times 6, 1 plus 6 is 7. That doesn't work. 2 times 3, 2 plus 3 equals 5. There's my number. So I'm going to rewrite 3x squared plus 5x plus 2. I keep my 3x squared. I'm going to rewrite 5x as plus 2x plus 3x, because 5x is 2x plus 3x plus 2. So I rewrote my middle term. Okay. I rewrote that middle term of 5x. I'm going to use, okay, 5x got rewritten as 2x plus 3x, because 2x plus 3x is 5x. Now I'm going to factor by grouping. First 2, last 2. Notice how you always put the sign in front of your number and inside the parenthesis on the second parenthesis. The greatest common factor out of 3x squared plus 2x. I can factor out an x again. So I'm left with 3x plus 2. And if I look at this with the greatest common factor of 3x plus 2, you might look at that and go, there is nothing. Remember, when there's no greatest common factor, the greatest common factor is always 1. If I factor out a 1, I'm left with whatever I had to begin with, which was 3x plus 2. So my common term is 3x plus 2, so I will write that down. And what is left over is x plus 1. So there we have it. There is the second factoring. Okay, let's take a look at number 3 here. This one's a little bit bigger because I'm looking at this going, woo, wow, my product is a little bigger. My product is equal to 42. My sum is equal to 13. Okay. Well, I know 1 times 42 is not going to work, but they both have to be positive. And if they have to be 13, they're not going to be super far apart. So I know it's not 2 and 21. Okay. I could do 3, but I'm thinking 6 times 7, because I think 6 times 7 is 42. 6 plus 7 is equal to 13. So there I have it. So I'm going to rewrite this polynomial 21x squared plus 6x plus 7x plus 2. Group first 2, last 2. The greatest common factor out of 21x squared plus 6x, I can take out a 3 and an x. So I'm going to take out a 3x. If I divide 21 by 3x, I get 7x. If I take 6x and divide it by 3x, I get 2. Greatest common factor out of 7x plus 2 is 1 again. So I put that 1 down there, and I'm left with 7x plus 2. So my common term, 7x plus 2. What is left over? 3x plus 1. So the factorization of 21x squared plus 13x plus 2 is 7x plus 2 times 3x plus 1. Let's work out a few more problems, because this is new and it can be a little confusing, so I'm going to do a lot of examples here. If we look at 8x squared plus 10x minus 3, I need a product of 8 times negative 3, so I need a product of negative 24. I need a sum of positive 10. So the only way I'm going to get a product that's negative and a sum that's positive is one factor is negative, one factor is positive. And obviously the larger of the two factors has to be the positive factor. Okay, so if I do negative 1 times 24, that will give me negative 1 plus 24 is positive 23. That's not 10. Negative 2 times 12, negative 2 plus 12 is positive 10. There we go. There's my two factors. My factors are negative 2 and 12. So I rewrite my 10x as negative 2x plus 12x. So I keep my first term, 8x squared. Rewrite 10x as minus 2x plus 12x. And it really doesn't matter which order you put those in. It'll work either way. Minus 3. Keep factor first 2, group second 2. Greatest common factor out of 8x squared minus 2x. I can take a 2 and an x out of that. So 8x squared divided by 2x squared. 8 divided by 2 is 4. X squared divided by x is x. 2x divided by 2x is 1. It's not 0. Be careful with that. I get a lot of people who try to tell me 2x divided by 2x goes away. It doesn't go away. It's a 1. Greatest common factor out of 12x minus 3. That would be 3. 12 divided by 3 is 4x. Negative 3 divided by 3 is negative 1. So we have our common term of 4x minus 1. And what's left over? 2x plus 3. So there's our factorization of 8x squared plus 10x minus 3. Number 5, 6x squared minus 41x minus 7. I need a product of 6 times negative 7, which is negative 42, and a sum of negative 41. Here's the deal. I know my numbers have to be really far apart for me to get a sum of negative 41. And the larger of the two factors has to be negative. So I'm thinking 1 and negative 42. Because 1 plus negative 42 is equal to negative 41. So rewrite this as 6x squared plus 1x minus 42x minus 7. Group the first two, group the last two. Notice the negative sign in front of the 42 goes inside of that parenthesis. That's really important. Greatest common factor out of 6x squared plus 1x. Well, there's no number, but I can take out an x. So if I factor out an x, 6x squared divided by x is 6x. 1x divided by x is just 1. Greatest common factor out of negative 42x minus 7 is a negative 7. Remember, you always want to take a negative out if your first term is negative. I divide by negative 7. Negative 42 divided by negative 7 is positive 6x. Negative 7 divided by negative 7 is positive 1. And there's my common term. So 6x plus 1 times x minus 7. And I have factored that one. Now sometimes, these were really nice. We didn't have anything that we had to worry about a greatest common factor. Sometimes you have to factor out a greatest common factor first. And that's really, really important, because if you don't, you can still factor it, but it's much, much, much more difficult because you're going to have much larger numbers. And then at the end, you're going to have to notice that you still have a greatest common factor, and you're still going to have to factor it out anyway. So let's take a look at number 6. 9a squared minus 15a minus 6. I'm looking at that going, ooh, I can divide everything by 3. So my GCF has to be 3. So I'm going to take out a 3 first. 9 divided by 3 is 3, so I have 3a squared. Negative 15 divided by 3 is negative 5, minus 5a. Negative 6 divided by 3 is negative 2. So now I need a product of negative 6 and a sum of negative 5. So one factor's got to be positive, one factor has to be negative, and the larger of the two factors has to be the negative factor. I am thinking 1 times negative 6, because 1 plus negative 6 is negative 5, so that works. So I'm going to take just what's in the parenthesis here, just the 3a squared minus 5a minus 2, and rewrite that. So I have 3a squared plus 1a minus 6a minus 2. So all I did was, again, rewrite 5a as positive 1a minus 6a. Group first 2, last 2. Greatest common factor out of 3a squared plus 1a, I can take an a out. And I'm left with 3a plus 1. Greatest common factor out of negative 6a minus 2 is a negative 2. And that will, negative 6 divided by negative 2 is positive 3a. Negative 2 divided by negative 2 is positive 1. Common factor, 3a plus 1. What is left? A minus 2. And don't forget, we took a GCF out to begin with. We need to put it back in at the end. So we have to have that 3 that we took out at the very first step and put it back. So we have 3 times 3a plus 1 times a minus 2. Number 7. 18x squared plus 36x minus 14. Greatest common factor here. I'm looking at that going another all even, so 2. Because 6 goes into 18 and 36, but it doesn't go into 14, so it has to be 2. So if I take a 2 out, 18 divided by 2 is 9, so that gives me 9x squared. 36 divided by 2 is 18, so that gives me 18x. Negative 14 divided by 2 is negative 7. So now I need a product of 9 times negative 7, which is negative 63, and a sum of positive 18. Okay, so I'm like, 1 and 63, no. 63 is not divisible by 2, but it is divisible by 3. So let's try negative 3 times 21. Negative 3 plus 21 is equal to positive 18. That works. So let's rewrite 9x squared plus 18x minus 7. So we have 9x squared. 18x gets rewritten as negative 3x plus 21x minus 7. Group first 2, last 2. Greatest common factor out of 9x squared minus 3x is a 3x. 9 divided by 3 is 3, so 3x. Negative 3x divided by 3x is negative 1. Greatest common factor out of 21x minus 7 is a positive 7. 21 divided by 7 is 3x. Negative 7 divided by positive 7 is negative 1. So my common term is 3x minus 1. What is left is 3x plus 7. And don't forget you had a greatest common factor. You have to put that back at the end, so we have to put that 2 back into the final problem. That'll be the biggest thing that people will forget. They'll forget to put that 2 back in. Remember, you can always check it, multiply it back together, and make sure you get back to the original problem. And if you don't, look to see if you made sure you've put down everything that you factored out of it to begin with. All right, 2 more examples. 6m squared plus 15mn minus 9n squared. Ooh, look, we have m's and n's. We have 2 different variables in this one. Don't let it confuse you. It's still the same process as we did before. So I'm looking for a GCF. Looks like 3. So if I divide by 3, 6m squared divided by 3 is 2m squared. 15mn divided by 3 is 5mn. Negative 9n squared divided by 3 is negative 3n squared. So I now need a product of negative 6 and a sum of 5. The only difference now is instead of writing 5 as 5m and something m plus something m, I'm going to do something mn because my middle term is an m and an n. So I need a negative product and a positive sum, so my negative factor has to be the smaller one. So negative 1 times 6, because negative 1 plus 6 is negative 5. So I'm going to rewrite 5mn. So I have 2m squared minus 1mn. That's the only difference. We just need to make sure that we add the middle term here. Before we only had 1 variable, now we have 2. Plus 6mn. Whoops. N is not an n exponent. Minus 3n squared. So we rewrote 5mn as negative 1mn plus 6mn. Group first 2, group last 2. What can I take out of 2m squared minus 1mn? I can take out an m. If I take out an m, I'm left with 2m minus n, or 1n. Out of 6mn minus 3n squared, I can take out a 3n. So let's take out a 3 and an n. 6mn divided by 3n is 2m. Negative 3n squared divided by positive 3n is minus 1n. So there we have our common term, 2m minus n. What's left over, m plus 3n. And our GCF that we took out to begin with, which was 3. And that's the factorization of that problem. Let's look at example number 9. 18k squared minus 12k minus 6. There's a greatest common factor of this one, which happens to be 6 this time. So if I take out a 6, I'm left with 3k squared. Negative 12 divided by 6 is negative 2k. Negative 6 divided by negative 6, or positive 6, is negative 1. So I need a product of negative 3 and a sum of negative 2, which means my larger of my two factors has to be negative. So we're taking 1 times negative 3 because 1 plus negative 3 is equal to negative 2. So rewrite 3k squared minus 2k minus 1. So 3k squared plus 1k minus 3k minus 1. All we redid was we rewrote 3k, negative 2k as 1k minus 3k. Group the first two, group the last two. Greatest common factor out of 3k squared plus 1k, I can take a k out. If I take a k out, I'm left with 3k plus 1. Greatest common factor out of negative 3k minus 1, well, my first term is negative, so take out a negative, and the only negative I can take out is a 1. So that gives me 3k plus 1. So my common term is 3k plus 1. My leftover term is k minus 1. That would be this and this. And don't forget you took a GCF out, so we have to put that back, and that is 6. So 6 parentheses 3k plus 1 parentheses k minus 1. Now you can also do word problems with this. Let's apply it to this word problem. The area of a rectangle is 8x squared plus 22x plus 15. What are the possible dimensions of my rectangle? Which basically means I would need to be factoring this. I have to divide it out. So I'm going to divide out 8x squared plus 22x plus 15. So 8x squared plus 22x plus 15. First thing I'm going to do is I'm going to look for a GCF. Well, out of 8 and 22, it's 2. But there's nothing that goes into both 8, 22, and 15, so there's no greatest common factor. So I need a product of 8 times 15, which happens to be 120, and a sum of 22. Ooh, that's going to be fun. All right, so I know it's not going to be 1, and I know it's not going to be 2. Let's start with 3. So 3 times 40. Nope. 3 plus 40 is 43. That's too big. 4 times 30. Now 4 plus 30 is going to be 34. Getting closer. 5. 5 divides into 120. 5 times 24. 24 plus 5. 5 plus 24 is 29. We're getting closer. 6. 6 goes into that times 20. 6 plus 20 is 26. We're getting closer yet. I know 7 doesn't, but 8 might. Let's see. 8 times 15. 8 plus 15 is 23. We're getting really close now. I know 9 doesn't, but 10 does. 10 times 12. Oh, gee, I should have thought that to begin with. 10 plus 12 is 22. Notice how you systematically go through it so you don't miss what you don't miss. Some people would have gotten this right off the bat. I decided to do it the long way. Okay, so it's 10 and 12. So I'm going to have 8x squared plus 10x plus 12x plus 15. All I did was rewrite 22x as 12x and plus 10x. Group first 2, last 2. Greatest common factor out of 8x squared plus 10x is a 2x. 8x squared divided by 2x, 2 goes into 8 4 times, x squared divided by x is x. 10x divided by 2x, 2 goes into 10 5 times, x divided by x is 1, so it's just 4x plus 5. Greatest common factor out of 12x plus 15 is a 3. 12 divided by 3 is 4x. 12x divided by 3, I should say. 15 divided by 3 is 5. So my common term, 4x plus 5. What is left over? 2x plus 3. Since it is a word problem, I have to write my answer in a complete sentence. So the dimensions are 4x plus 5, excuse me, not 15, and 2x plus 3. And that's the dimensions of my rectangle. And I could say units because I don't know if it's meters or inches or feet. So you could probably put a unit down there and say the dimensions are 4x plus 5 and 2x plus 3 units. And finally, we get to our closure question. How do you determine how to rewrite the middle term of a trinomial that has a leading coefficient? How do you determine how to rewrite the middle term of a trinomial that has a leading coefficient? I pretty much told you this about 9 times, so you should have no problem answering that.